Take a slow breath in and a slower breath out. Let your shoulders soften. Let your eyes rest. Tonight is not about productivity. It's about understanding something real, something you rely on every day. A circuit breaker. A circuit breaker is a protective switch inside your electrical panel. Its job is to automatically open a circuit when current becomes unsafe, not because something is wrong with you, not because you failed, but because the system is doing what it was designed to do: limit heat, limit risk, protect wiring. Now, picture your home's electrical system as a tree. At the trunk is the main panel. From it branch out multiple branch circuits. A branch circuit is a dedicated path of conductors that supplies a set of outlets, lights, or appliances. That's why your panel has many breakers, not one. It's also why a problem can be local. One room goes dark, the rest of the building stays calm. Now, what does too much current really mean? Current is the flow of electric charge through a conductor. When current increases, the conductor can heat up. And heat is the core reason breakers exist. Wires and walls are sized for a certain amount of current. If you exceed that for long enough, insulation can degrade, connections can loosen, heat can build where you can't see it. So the breaker is primarily there to protect the fixed wiring, the building's electrical paths, not your laptop, not your fancy coffee machine, the wiring. Now let's get a little more specific. There are a few common events a breaker is meant to respond to. 1. Overload. An overload is when a circuit draws more current than it's designed to carry for a sustained period. This can happen when you stack loads on one circuit: a space heater, a kettle, a microwave, a hairdryer, not all at once ideally. Overloads tend to create heating over time. 2. Short circuit. A short circuit is when current takes a path that bypasses the intended load, often due to insulation failure or a fault where conductors touch. Short circuits can cause very high current very quickly. That's why breakers can trip suddenly. 3. Ground fault. A ground fault is when current leaks from the intended conductor to ground, often through a damaged cable, moisture, or a faulty device. Ground faults matter because they can involve surfaces you can touch. Now, breathe in and out. You don't need to memorize these. Just let your brain enjoy the structure. Overload, too much, too long. Short circuit, wrong path, very fast. Ground fault, leakage where it shouldn't be. Now, what's inside a breaker? At a high level, many breakers use two protective behaviors. A thermal response for overloads, heat-related, slower. A magnetic response for short circuits, fast, high current. You don't have to see it, you just have to know. The breaker is built to react differently depending on the kind of problem. Now let's talk about your panel layout. Most panels include a main disconnect, main breaker, that can shut off power to the whole panel, multiple branch breakers for individual circuits, a labeling system, sometimes messy, sometimes accurate, that maps breakers to areas or loads. When a breaker trips, the handle often sits in a middle position. That's the system telling you, I opened this circuit. Resetting is usually a deliberate motion. Switch fully to off, then back to on. That full off step matters because it resets the mechanism. Now, here's a calm, practical way to think about why it tripped. A breaker trip is not random. It's a protective decision based on current. So your quiet competence approach is, notice what stopped working, which outlets, which room, which appliance. Reduce load. Unplug a few devices on that circuit. Reset once, calmly. If it trips again quickly, stop forcing it. Repeated tripping is information. It suggests overload, a fault, or a device issue that needs attention. Now, a gentle but important boundary. If you ever see heat damage, smell burning, or see discoloration around outlets or the panel, that's not a wind-down problem. That's a get-help problem. Your job is not to be brave. Your job is to be safe. Now let's connect this back to presence. Circuit breakers are a physical example of a good system design principle. Separate circuits, clear limits, automatic protection. Instead of one giant fragile path, you have multiple contained paths. Instead of hoping nothing goes wrong, you have a mechanism that interrupts risk. And that's a nice thing to borrow for your evening. If your brain has been overloaded, you can open the circuit. Not forever, just for now. Now, a short guided reset. Bring your attention to your breath and imagine a simple electrical diagram. A loop, a load, a switch. When the switch is closed, current flows. When the switch opens, the flow stops. No shame, no drama, just protection. Breathe in for 4. 1, 2, 3, 4. Breathe out for 6. 1, 2, 3, 4, 5, 6. Again. In. 1, 2, 3, 4. Out. 1, 2, 3, 4, 5, 6. And quietly say, tonight, I can reduce the load. I can reset. I can return. Get calm. Get curious. Good night.